This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will be looking at negative indices and how to think about them and how to use them. So previously we saw what it meant to raise a number to the power of another number, which is in the set of natural numbers denoted by our squiggly n, and it corresponded to repeated multiplication. But what if we take a number and raise it to the power of another number in the set of integers, which would include the negative numbers and 0? If positive numbers or positive powers were repeated multiplication, what does negative powers and 0 mean? So firstly, we'll think about what a negative integer power really even means and where we see them. So a way of representing really large numbers is to use positive whole number powers. So we can see here that 10 to the power of 9 is a representation of 1 billion. But we can also use 10 to the power of minus 9, which is equal to 0.000000001, where the 1 is in the 9th decimal place. So negative powers are used for very small numbers. It's often used to represent size, such as the mass of an electron, which is 9.109 times 10 to the power of minus 31 kilograms. And this uses scientific notation, which will be discussed in a future video. So what we would like to do is come up with some way of defining numbers raised to a negative power. That is, we want to give meaning to an expression like 3 to the power of minus 4, the same way we gave meaning to an expression like 3 to the power of 4. It would be 3 by itself 4 times. So let's consider the powers of 3 that we will be familiar with by now. So 3 to the power of 1, if we multiply that by 3, we get 3 squared. Multiply again by 3, we get 3 cubed, and so on. So moving to the right in this diagram, we need to multiply by 3. But what if we wanted to move to the left in the opposite direction? So we wanted to go from 3 cubed to 3 squared, say, or 3 squared to 3 to the power of 1. Well, if we divide by 3, we can move one step to the left. So looking here, 3 to the power of 5 divided by 3 is 3 to the power of 4. Divide again by 3 is 3 to the power of 3, and so on until we get to 3 to the power of 1. But why stop there? We know what 3 to the power of 1 is, so let's divide by 3 and it should give us what 3 to the power of 0 is. So 3 to the power of 0 will equal to 3 to the power of 1 divided by 3. So that's just continuing on by dividing by 3, moving to the left, which is 3 divided by 3, which is 1. So 3 to the power of 0 is 1. And we can keep going to get negative powers as well. So 3 to the minus 1 will equal to 3 to the 0 divided by 3, which is equal to 1 divided by 3, which is 1 over 3. And again, 3 to the minus 2 is 3 to the minus 1 divided by 3, which is 1/3 divided by 3, which is 1 over 9. It's important to note that this 3 to the 0 equaling 1 is not just unique to 3, and that any number to the power of 0 is indeed 1. So now we have some idea of how we should define negative indices. And we notice that 3 to the power of minus 2, as we saw on this slide, was 1 over 9. What that means is 3 to the power of minus 2 can be written as 1 over 3 squared, because 3 squared is 9. And this can go on. So 3 to the power of minus 3 is equal to 1 over 3 cubed. So we can see that the minus in the power nearly represents 1 over. So we have the following rule, which allows us to define negative indices. A, being any real number, to the power of minus k is equal to 1 over a to the power of k.